It's now the early 1800s. John Dalton is a teacher who does research in his spare time. He's trying to piece together the structure of the atom. He looked at Lavoisier's law of conservation of matter and at Democritus's idea of atoms, and it got him thinking, what if matter is made of indivisible particles that rearrange but do not disappear? Dalton started doing his own experiments. In 1801, John Dalton conducted experiments on how gases mix and on how their individual pressures contribute to the total pressure of a gas mixture. He found that the total pressure of a gas mixture equals the sum of the partial pressures of the individual gases in that mixture, according to this equation. The total pressure of gases in a mixture equals the pressure exerted by component number 1 plus the pressure exerted by gas component number 2, and just keep adding them. However many gas components you have, that's how many terms need to be added together. Let me explain. Let's say you have 0.60 moles of hydrogen gas in a closed container, and it exerts a pressure of 2.9 atmospheres. In that same container, but in a different experiment, let's say you had 1.50 moles of helium, which exerted a pressure of 7.2 atmospheres. If both of these gases are combined in this same container, their pressure is 10.1 atmospheres. We get that from 2.9 atmospheres of hydrogen plus 7.2 atmospheres of helium equals a total of 10.1 atmospheres. Likewise, the number of moles of gas when the total is mixed is, you can also just add these. 0.60 plus 1.50 equals 2.10 moles of gas total. John Dalton's law of partial pressures supports the idea that at least gases are made of tiny particles or atoms that are separate from each other. It supports the idea that in chemical reactions, atoms are combined, separated, rearranged, but not created or destroyed. In 1807, Dalton pieced together everything we've discovered so far from ancient Greece until now into Dalton's atomic theory. All matter is composed of extremely small particles called atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements can combine in simple whole number ratios to form chemical compounds. In chemical reactions, atoms are combined, separated, or rearranged. What does this mean for the structure of the atom? Well, this list is our best knowledge at this point in time, but they're not all correct. Atomic structure is more complicated than just little indivisible spheres. We're starting to piece together what atoms are, but by 1807, we still don't have enough information to piece together atomic structure. If you want a moment to propose your own atomic structure, pause now because I'm about to show you Dalton's atomic model. Maybe atoms are like billiard balls, indivisible, solid, and distinct for each element. When they combine, they stack into precise whole number ratios, explaining definite proportions. Maybe water is H2O because two small hydrogen spheres fit perfectly into one larger oxygen sphere. No half spheres or in-between sizes exist. This explains the law of partial pressures because gas atoms don't interact much. Each gas presses against the walls of the container independently, just like billiard balls in a box hitting the walls. John Dalton was a school teacher who went down in history for his scientific breakthroughs. I'd like to follow in his footsteps, except for the part where he was ignored at first, so I need both of you who are watching this video to click that like button. Thanks for watching Chemistry in a Nutshell.